You'll find that my interests are quite eclectic. I do have a number of things. For instance, when we talk about when we talk, like I use this book over here, which is How to Cheat at Everything. A Con Man Reveals the Secrets of the Esoteric Trade of Cheating, Scams, and Hustles. We'll be talking about that during Monte Carlo methods because what makes scams and scam games so successful is that they present the odds in a way, and at the initial glance, the odds look like they are even or even in your favor. But in reality, once you do a statistical analysis of it, they're actually they are they are way stacked against you. Now, as far as music and technology, I would love to talk about, if anybody's interested, I would be able to talk about that with them during office hours. I've done some interesting things. My big thing right now that I'm really interested in, want to get into, and it's a completely different field for me to research, but it's the entire field of media synthesis, which is the idea of basically people of producing, having computers produce works of music, having it produce works of text, like using GPT-3, or my personal favorite is this person does not exist. Let me go ahead and share my screen for a second. Right, this person does not exist, which is this is exactly what it says. This person does not exist. Refresh your page and you'll get a new generated person who does not exist. This is a completely fake and altered picture generated by StyleGAN, which is produced by NVIDIA and a bunch of other stuff. Another person that does not exist. We haven't seen anything that doesn't look too out of the ordinary yet. It's actually really impressive that it messes up on some stuff. Let's see, chat. What's in my chat now? Hold on. So let's see. Arts, cats, chemicals. So, sorry, I'm just trying to look for my chat window. And yes, I do remember what I said about Pokemon being the subject of today. Now you may, let's see. So let's see. This artwork does not exist. Oh, look. Generating wallpaper. Let's see. This cat does not exist. I like modern art. I didn't used to. Okay, that's cool. That is really cool. Some things, though, are just pretty boring. This chemical does not exist. That's really cool. I don't need you to access my virtual reality. So these are just things that are being produced by machine learning. Okay, that looks kind of like the eyes give it away, kind of. Would make me say, that's cute. That's also cute. Fearsome. All right, but basically these are all being generated by something called generative adversarial networks, which are basically two machine learning algorithms working against each other to produce different results. It's really cool. Something I really want to learn how to do. So there is going to be a great intersection between the arts and computer science. And if you are artistically inclined, I highly suggest you take a look at that. So now let's go ahead and talk about, get talking about our things for today. So today I'm going to use a fairly large data set to do some statistics on. The data set that I'm going to be working on is Pokemon, which, in case you didn't know, is the largest or the highest grossing franchise in the world. Right? So in case you're wondering, right, it is worth more than Star Wars in terms of total revenue. There's a lot of money in Pokemon. Now, for those of you who are unaware, Pokemon is a Japanese based a role-playing game where players basically essentially capture wild enemies, animals, and put them into and fight them against each other. And somehow this is portrayed as okay. But I love, that being said, I love Pokemon. It's a great game. Anyway, Pokemon, and it's actually played quite competitively. Generally what you do, generally you have teams of 6, you choose 2, and in competitive versions you choose, of 6, you choose 4 and send them out in pairs. It's pretty cool. It's pretty wild. And there's prize money involved. So of course people are into it. So anyway, here, Bulbapedia is essentially the Wikipedia for Pokemon. And just in case you're wondering, it's, if you're ever thinking about making video games, take a look at stuff like this and look at the kind of math and the balancing statistics that go into like just calculating how much damage will be done, right? Or how do we generate so here's like the equations for generating HP for Pokemon. In other words, how much damage they can take. So there is a lot of math that goes on to these things, although I doubt like somebody just kind of like, okay, yeah, the way we need to calculate HP has to be this. Instead, they probably tweaked it and thought, yeah, that looks great. So anyway, getting a bunch of Pokemon. So let's first off just remember that anytime you're so first we need to get data. Remember, anytime you're dealing with an HTML web page, or well, anyway, a web page, which are only in HTML, you can always view the source because that's essentially what your computer sees, right? Because my computer sees, come on, you can do it. Seriously? You're going to quit on me now? Must be a really large page. Firefox, you know, it was a fresh install. All right, Edge, it's your turn. Your turn to shine. Certainly you can do fine. Oh, no, here it is. Sorry, Edge, you'll have to, oh, not zooming in appropriately. All right, Edge, let's go ahead and see what you can do. So let's go ahead and view page source. Oh, notice that the web page source is actually pretty large. Oh, but here it is in Edge, and that's okay. So let's go ahead and zoom in. Right, it is just a giant text file with a bunch of entries and stuff. Parsing that would be a pain. Let me go ahead and mute everybody because somebody accidentally has their mic on and it is distracting to me.
Yep, down.
There we go. Okay, so it is quite the large thing. And it turns out that web browsers don't like working with large files. That's okay. So anyway. See, just doesn't like it. Doesn't like it at all. So how do we get this data out? Well, there's a couple ways. The easiest way, of course, is good old copy paste. So what I'm going to do is just simply grab this, scroll down, and then we've got a couple ways to do this. Let's see what happens if I paste this into VS Code. All right, so there we go. So we've got a fairly large list. We have not everything though. Not everybody got copied over. We only got up to 110. We only got up to Hitmonlee. Why is that? Okay. Why is that? I did this last year. Worst case scenario, I'm going to just grab the file I grabbed from last year. So you just simply, so let's try this again. Let's just go ahead and grab, starting here. Okay, and so there we go. So we've got, okay. So here we've got basically, this over here was, sorry. So basically let's take a look at what we get for the Pokemon. We've got 2 fields where they have their number. I'm we're getting a repeat because of the picture that we copied. We have the name, and then we have their statistics, and then we have the average of those statistics. Sorry, we have their statistics, we have the sum of those statistics, and we have the average of those statistics, right? Let's grab what those statistics were. So certainly we can do this, I say, hopefully. So let's go ahead and do this. And we don't need that. Pokemon, HP. And so now let's go ahead and do num and num2. Okay, so tab. Interesting. Copied the tab over there. And copy the tab. Because it's working. Okay. So now we have essentially what we could consider to be a comma separated file. I'm going to actually comma separate it, and I'll get into what that means for a second. So give me a second. Find. So can I replace the tabs with commas? /t match case. Yes, I can. And let's go ahead and replace them all with commas, because I want to actually make it a comma separated file. There we go. So we are going to save this in Classroom, ITP, Fall 2020, Pokemon.csv. Save as file type. Let's give it, and I'm going to just say no extension because of course not. Save. There we go. So this is a CSV file. So CSV file is a type of text file. If you ever work with Excel, right? In fact, if I go and look at this up in the browser, right? So I'm going to go ahead and look for my Pokemon file, which is in here, users. My wife is probably very confused if she's hearing me talk about Pokemon. She's like, don't you have a class? I know you like that game, but I didn't think you liked it that much. Okay. Classroom. Okay. So again, the reason I like this is that it is large, but it is not unreasonably large of a file. Okay. And it also showed us how easy it is to just grab data from the internet and kind of create our own file without much of an issue. So here, right, if I open this, this is going to open up in Excel. CSVs by default in Windows open up with this Excel. Don't show again. And here, let me zoom in. So what we see here is this file automatically loaded into Excel, and notice the lack of commas. So, and if I were to export this file in Excel, if I were to take any kind of Excel file, and if you're working in any kind of file Excel, let's go ahead and create a new one. And I'm just going to create use a different account. Told you. But so I won't be able to save this because, of course, except yes, I know. Okay. So 1, 2. Okay. Yes, I know it has to be activated. 3. So if I were to save this, I could save it as a, and let me disable my flow right here, because I was kept going into the other computer. So file, save as, and then I can save it as a, let's go ahead. I could save it as a Excel workbook, but you can also save it as a CSV, a comma separated value. So any file can be saved as in Excel, can be saved as a CSV, or can be exported as a comma separated value file. And all a comma separated value file is basically something that could be easily loaded up into like a programming language or easily imported. It is just a bunch of data separated in rows, and each row has their own data items separated by commas. So we look for some delimiter, typically a comma, to say, hey, if I see a comma, that's not actually anything to do with any data you see in there. That tells you where one data field is intersecting, ends and another one begins. So we can work with this. So let's go ahead and create a new Python file. So I'm just going to create a new file here. Notice I created a new text document. If I wasn't actually, so and there's a couple ways I create new files. So one way I can do this is I can just do that, and now I can rename it into Pokemon reader.py, and now that just changes it into a Python file. Another way to do that, if you're running in any kind of bash or a terminal like you are in a Mac, one useful command you have, and I know it's super hard to see there, so can I open terminal here? Whatever, open bash here. So what you can do is you can say touch, and then you can give it a file name like myfile.py, and that will create a file of that name right where you told it to, which is pretty cool if you're running a Mac or any kind of Linux. So, okay, let's go ahead and open up our Pokemon Reader. I'm going to open it up with, I'm going to go ahead and more apps. You know what? Look at that. Modern IDEs are amazing. You can drag and drop them. Things in modern languages work the way you would expect them. The element of least surprise is a very important programming concept. So here, what I did to open it was I just simply grabbed it from the desktop and dragged it over here, and that worked. There are a lot of convenient features built into operating systems these days to make your life easier, right? Don't be afraid to take advantage of them. So first off, let's go ahead and open up this file. To open up the file, we are going to go open, and then we give it the file name, Pokemon.csv. And then we are going to go ahead and then we say we are going to read it. So I'm going to say data is equal to open. And again, what this does is this gives us a pointer. This gives us a data object. So I'm going to print data. All right, so this gives us a text IO wrapper saying, hey, this is a wrapper of text. It's not actually anything in it. This is essentially the connection that you've created to be able to read the text, right? This is not the this is not the data itself. This is how we go through the data, or it's our means of using it. It's the abstraction. And the way I like to do it is for line in data, so I can iterate through this because it provides a function to iterate through it, and I can say, hey, print the line of text, and then run it. And it's super easy. It just spits out all the data, right? Now, we got this extra line here because because every single line over here does have a new line character right at the end, right? So it's reading the file, it reads the line, including that new line character, and then I tell it to print it out. So it prints it out, including the new line character, and then print tells it to go ahead and create another new line. So that's why we're getting it double spaced, essentially. To deal with that, we have two ways of getting around that. We can say end is equal to nothing. So we don't end our line with a new line. We just print it out. The other way we can do that is we can, which is what I prefer, and the other way, this is simpler, but I prefer the other way to do it, which is just simply to take our line and just start modifying it. So line is equal to line.strip. Strip cleans up the line, right? And of course, it doesn't print anything out because I didn't tell it to print. So it removes all the beginning and ending and trailing white space. So any extra spaces at the beginning, any extra spaces at the end, automatically removed. Cool. So let's continue on. So what fields do we have? We have, oh, and look, it didn't print out the entire file, right? Remember, this happens sometimes when we're dealing with large text files where there's just too much data for our console to print out, right? It's not that it didn't read the first parts of this file. It was just too much. Let me go ahead and split this so I don't have to change my tabs. Right. So splitting. So this is another feature in a lot of different IDEs where basically you can, if your IDE uses tabs, often has the capability to split it vertically or horizontally. So this is very useful, especially if you've got a wide screen. Okay. And notice again, I've got the text size bumped up, but that doesn't really matter for me too much. So let's go ahead and now look at this. So we have, so in a CSV file, typically your first line is a key, right? It's not data, it just tells you what's in it. So we can typically ignore that one. Or especially we're going to need to ignore that one when we look at all of the stats. So the stats are, let's see. So we've got, let's go ahead and copy this over to just remind us, and we're going to put in a comment. num2. So this, again, this guy came from basically the fact that it copied over the picture and it needed a placeholder for the picture. So the number, the other number is that. So these are, I'm just simply labeling the fields now starting at index 0, right? I'm just trying to give you a sense of how you work with data like this, because you're going to be doing something very much like this with the hurricane tracker assignment. 8, 9, and then average is 10. Okay, so we've got those, and now the reason I split it, I did that was because, oh, and this is a cool feature. Again, let me mute everybody. Okay, this is a cool feature. If I do this, I think I can slice our data. Let me see if I can slice the data. Can I slice our data? No, you cannot subscript it. So I don't have a way of ignoring the first line, so to speak, right? 4-line in data, you gotta read everything. You can't slice it. So what am I gonna do instead? Well, I'll go ahead and use the other way, which is that I will say lines is equal to, so these are all the, or this is all the lines of data is equal to data dot read lines. And this just simply reads the entire file and dumps it into there, with each line being its own specific thing. So for lines and lines, print out the line like that. So lines here, lines is a list here of strings. For each string in the list of strings, what am I doing? I'm cleaning it up, and then I'm printing out that individual string, which is why we don't get the brackets. Okay. So now suppose I just wanted to print out the Pokemon's number. Well, in that case, all I have to do is, well, there's something I can do then. I can say fields is equal to line dot split. And this is the value of working with a comma separated file. I can split it up by the comma. And now watch. I can turn every string into a list with each of the data fields accessible individually. Everybody see that? What the split did? Remember, split takes some delimiter, like say a comma, for instance, and says, I want to separate out this field or this line or this string by separating it I want to separate it into different sections. And those different sections, we split it according to where the commas are. So again, over here, we aren't printing out the whole thing because of limitations, but now I can say, hey, print fields 0, and I'll just print out the number. And again, there's a maximum number of lines that this is willing to print out for me. So let's go ahead, and so now we can do some stuff. So if we look at our key that we made for ourselves, HP is 3. So let's go ahead and figure out what the average HP is. So now how do we figure out the average? The average is the total divided by the count. And there's going to be an intentional mistake here. So don't that's going to prevent it from running, just a heads up. So what we can do if we want to calculate the average HP is that we can take a count of how many Pokemon there are. So how many lines there are. Count is equal to count plus 1. And then total HP, right? That's at field 3 plus equals field 3. All right. Print total HP divided by count. And this should give us the error, but we're going to get a unsupported operands types for int and string. Oh, right. Int is a field. This is a string, right? And when we split it, it doesn't automatically turn them into ints. So I got to turn these numbers into ints myself, right? So let's do that. And invalid literal for int 10 with base 10 HP. Well, remember, this first line gets read, and then this is field 3 in that first line. So we just tried to turn an integer we just tried to turn the string HP into an integer. That's not going to work. So going back to what I was alluding to earlier, what I'm going to do is I'm going to just simply iterate over everything but the index 0. I'm going to iterate over everything but the very first line. Okay. Zen mode. Did I miscount? 0, 1, 2, 3. So where am I seeing Zen mode? Let's go ahead and see. Data, by the way, isn't always nice. It's sometimes very messy, in fact. And we look over here that this guy over here has a comma in his field. Well, let's go ahead and just clean up our data like that instead of just trying to make an exception for that specific guy. Okay, and we find out that basically that the average HP is 69.69. So let's go ahead and figure out how we can find the Pokemon with the most HP. Which Pokemon has the highest HP stat? Okay, so there's a couple different ways to do it. So the first way we can do it is just simply do it manually, which is this is the most efficient way to do it, which is simply to say max HP is equal to what's it? All right, 0. Right. So we're going to start off at 0, and we're going to iterate through all the HPs we see. And if we find somebody with a bigger HP, we are going to basically say that is the Pokemon now that has the biggest HP. So, right. So let's go ahead and play with that a bit. So now, let's go ahead and just create a field called HP is equal to int fields. So that will make it easier. Move that line up there. That was Alt up, by the way, that let me swap two lines like that. It's a pretty nice trick. HP. Okay, if HP is greater than max HP, right? If the HP we're currently looking at now is bigger than what we found previously, then HP is equal to, or rather, then we say that is the new max HP. So print max HP, and this should be 255, I believe. Right. Now I knew that because Pokemon basically is based off of games that when you're talking about stats, they're somewhere between 0 and 255, which can fit perfectly within 1 byte. That's so 255, right? So, but we want to find out which Pokemon that is. So let's go ahead and create a new field. Max HP Pokemon, all right, is equal to none. Okay. Or I'm just going to put in blank over here. So now when we find the Pokemon with the greater HP, let's actually record the name too. Max HP Pokemon is equal to, and we'll need the Pokemon's name, which is located at 0, 1, index 2. Fields 2. So now we can print out max HP, let's see, HP Pokemon. Okay, and now that was Blissey, which should be completely unsurprising to anybody who plays Pokemon. Blissey is an HP and special defense tank, but hit it with a regular attack and it will go down. Okay, so this is a very common thing, trying to find the biggest value in there. Let's go ahead and reverse this. Let's find the Pokemon with the smallest HP. Now this is a bit trickier, because I might say min HP, because if you try this and say min HP is equal to 0, well, you're looking for the thing with the smallest HP, right? You're looking for the thing with the smallest HP. But we'd be starting out by checking and saying, hey, is this smaller than 0? Is this smaller than 0? And we check every line and nothing would ever get updated, right? Because the smallest thing might not be smaller than 0. So that gives us a bit of a problem. So what we should do instead is, right, max HP, we're looking for the thing we keep looking for a bigger thing. So for min HP, we need to look for something that keeps getting smaller. So I'm just going to, put something in here and just basically say, hey, I'm just going to put in any very large starting value. Or I can take advantage of the fact that I know that the largest value, again, is 255, and just simply say, hey, and use that as my starting point. It really depends on your data set and what you're doing. In other programming languages, you can just simply do integer.maxint or something like that. Python doesn't have max size for the ints, but that doesn't matter. So, but this means that at the very first Pokemon we're going to grab is going to be, we're going to say if HP is less than min HP, then the first Pokemon will basically become the Pokemon with the smallest HP, and then we can figure everything else out from there. So, min HP Pokemon is equal to fields 2, and then min HP. Doesn't really matter what order I do those in. Okay, and so now we can print min HP Pokemon, min HP. Okay, and it says that it is Shed Ninja, which should be unsurprising to anybody who's played Pokemon again, because Shed Ninja only ever has 1 HP. So, so again, these kind of things, so these are extremely common operations we can do. Another way we can do this, okay, is that we can create a list of HPs, okay, and we can use our append method, right? Going back to what we learned on Tuesday, we can use the append method. So HP vals is equal to an empty list. Names is also equal to an empty list. And so I'm not going to bother removing the other code I have. You'd rarely run these two simultaneously, but I'm just trying to show you different ways of doing it. There are a lot of correct ways to do it in Python. So here, what I can do, right, instead of like going through line by line and comparing, is that I can just gather the data myself and then let Python figure it out after I've gathered all the data. So HP vals dot append HP. Let's go ahead and simplify this also. Okay, so I'm going to go over here and say name is equal to field 2. Okay, so name, make it symmetrical, name. So what we can do here is that, so alternatively, rather than doing this if else block, this is an alternative we can do over here. We can say HP vals. We simply just slap that HP value on the list, and then we can slap the name on the list. Names dot append names dot append name. Right, and now that we've got those, basically we can, I'll show you over here, we can just simply print out the list of HP values. Right, so now we have a value of all the HPs stored in a list. Now, the benefit of this is now I can just simply say, give me the largest value in that using the max function rather than using the if else statement. 255. But how do I get the Pokemon's name? That's tricky. Okay, so this is going to look a bit hacky. So I'm going to, once I do this, I'm going to break it up into multiple lines, but I'm just going to show you what it looks like in one line because I am a monster. So let's go ahead and say HP vals dot index max HP vals, and throw that into brackets. So, and throw that into name, and then we'll say max HP max HP. Go. String index out of range. So let's see. 144. What did I do wrong there? The issue with making large statements is that you can do wrong. So this HP vals of the list, this returns a number from the list. This tells me the index where that is located at in here. So that gives me the index, and then this should give me, oh, names. That's right. Names. There we go. So spelling error that time. So how many of you find this horrible and confusing and want to make you cry? Right. This is bad. What I just did here was mean and bad practice. I should not do that. Okay, apparently all this was, okay, apparently I missed all the chat. I'm sorry about that. So let me see that over there. So over here, so this is just so this kind of statement is the kind of statement you make after being comfortable programming in Python for a number of years. Okay. It is also highly inadvisable because it's not readable. So it's one of those kind of statements of like, just because you can doesn't mean you should. Am I able to drop this Pokemon file in chat? Let me go ahead and do that. I'm going to drop the file in chat. Sorry for everybody who doesn't have it. So, and again, I just dropped, I'm sorry, that only got sent to Meet. So let me go ahead and drop that to everybody. Boom. So over here, let's go ahead and take a look at what I've done. So I'm going to explain this. So let's start at the beginning, which is the inside statement. So first off, let's just put this over here. This doesn't matter. It's just simply telling me what the max value in HP vals is, which we know is 255, right? So max HP vals resolves to 255. Next thing we do is we ask hpvals.index of max HP vals, which is, so in other words, what is the index of 250? What is the index of this value in this list? So this says we can find this number in 255. I just posted the file in chat. So we say we can find this value at some index, okay? And then because we were adding the names and the HP at the same time, because we were adding them to the list at the same time, we can find which Pokemon goes to which value by looking at the same index in the names list. Okay. So let's go ahead and untangle that mess. And then I'm going to show you the third way to do that. Okay, because again, this is a mess. This is so let's go ahead and untangle, and then I'm going to move on to the third way. So max HP vals. So let's go ahead and find basically. So what we'll do here is we'll say max HP is equal to max HP vals. That gives us the Pokemon with the largest HP value, right? Now that we know the Pokemon, or now that we know the largest HP value, we'll say that index of max HP is equal to the index of max HP will be HP vals dot index of max HP. So in other words, tell me where I can find this thing. And then name is equal to, or then the max HP Pokemon is equal to names index of max HP. Okay. So max HP Pokemon, max HP. Of course, this is a bit confusing because we're moving with two lists, and I think this is the line that provides the most confusion for our students because, right, because why does this work? Well, every time I read HP, I'm also reading a name, and I'm storing them in separate lists. But I add index 0 for the first guy, then index 0 for the second guy, and then, sorry, index 0, then index 1, then index 2, index 3. They're paired together. So that leads me to the third way we could do something, which is why use, well, actually, that would probably be, no, I'm not going to do that way because that would just be annoying and frustrating. So ixnay on that idea because I think this is enough torture as it is. All right. So breaking things up into this makes it more readable. Now, let's see. So we could go through and also find out. So this is a fairly powerful thing. You can find the minimum, the maximum, and the average. On your next quiz, I would once I figure out how to put files on there, I would expect a question that basically, given a file, figure out what the minimum thing in the file is, the maximum thing in the file is, and the average thing in the file is. So I would know how to do this for your next quiz. Okay? Whenever that is, probably sometime next week. Okay. So we've talked about reading files. Now let's talk about writing files a bit. Okay, and then we're going to get started on writing a very basic text game. Okay, so how do we write files? File. Again, doing it in Java was a pain, a real pain, like terrible pain. Awful, god-awful pain. Because you had like nested layers of abstraction, and Python's like, nope, the way you write it, the way you tell me you want to write to a file is that you say, is you give me the file you want to write, and you can say whatever it is, just, so file write test.txt is equal to, sorry, and then we're going to say, instead of read right over here, we're going to do write. Okay. I'm going to say target is equal to this. And then to write to your file, you say target dot write. So let's go ahead and play with this a bit. There's no real preference between CSV and TSV. There's no difference. Yep, exactly, Peter. So let's go ahead and just type in target.write hello. And then target.write world. And we're going to do this a couple times. So run it. It doesn't crash and burn, which is great because that's always awful when that happens. So let's go ahead and look. And we see that we have a new file in here. It was created at 2:50 today. File write test. Let's open it, and it says hello world, which may have not been what you were expecting. It says hello world in one letter. By the way, wasn't too sure that was going to work, because technically what I should do after I write after I'm completely done with a file, especially when I'm writing it, is do this line over here, which says close it. That tells any other process that I'm done with it, and to please save all the data. So you got to have that in there. So hello world. So let's go ahead and try this again. Hello world. How are you? So we just got 3 write statements. Run this, and you can see it updated over here. Now we are in write mode, which means that we are overwriting this file anytime we do it. So we either create it from scratch or we're going to overwrite it. If we want to add on to it, we use something called append using A mode. Generally a bad idea to try to read and write at the same time. I don't think there probably is. I never had to do that. I highly recommend against it. So append mode, what that does is just simply slaps what you wrote onto the end of the text file. So note that that write isn't like print. It's not. It's telling us to do. It's doing exactly what we tell it to do, which is that it doesn't write a new line. So if I want new lines, I'll have to put them in myself. So now I run it. Hello world, how are you? So writing a file is pretty cool like that. And it's useful for when you want to save your data. like you're running processes and you're getting a lot of data points and you want to save it. So writing is useful like that. It's also useful because, I mean, you could print it out, but then you'd have to copy and paste it over into a file. And this just skips that process. You don't have to write it out to text. We can write it out to my special extension, whatever you want to do. Write it out, and it has no problem. You see, the dot in the name, what comes after that name is actually part of the name. This is all the name of the file. File write test, my special extension. What this does, though, the dot and the part after it is used by your operating system to say, what program should I open? What should I open? So if we go over here again, notice that it doesn't recognize my special extension file type. Again, let's just go ahead and extra large. But if I try opening it up in this program, because it's a text file, it's not going to have any issues being read. Generally, .text is used for data, or .csv is used for data, because it's just super useful to do it that way. Okay. File writing is not too exciting, except when it is. So, as opposed to a game, let's go ahead and write baby's first malware. So, first off, malware. Do not run any programs that on anybody else's computer that you don't like for your, sorry, that you don't want to be run on your own computer. Don't run any programs on any other person's without permission. Do not log on to anybody else's computer without permission, and use it. The things that I've listed above are felonies, believe it or not. We're talking go to jail felonies. Unauthorized computer use is a felony. I am not kidding here. So, so what we're going to show you here is basically a very dumb malware that I'm going to write, okay? Which is that I'm just going to basically waste a bunch of disk space, okay? So the way I do that is I'm going to go ahead and simply create a new file called first malware.py, right? And I'm going to go ahead and write, do not run on this, just so that people know not to run it, right? Of course, they'll open the source code and check it, right? But anyway, point being is that what we can do, since we can now write files to disk. So we can write files to disk. This did not take up that much space, 26 bytes, but it took up some space, right? So I could just, open, and you don't need to do this to your own computer. In fact, I suggest against it because it's very easy to just make a mess for yourself. Let's call it output.txt. So we're going to have some fun with this, and we're going to just make use of our for loops, right? So target is equal to output.txt. In fact, let's just remove the extension entirely because we don't plan on reading it. Let's go ahead and just do now target dot write all work and no play makes Jack a dull boy, right? Add in a period and a new line. And if we just simply, and then we say target dot close. Now, what I'm showing you, by the way, isn't so much malware or something you could accidentally do to yourself quite easily. So let's go ahead and see. So let's go ahead and see output. And to call it malware, by the way, is so overstating what this is. John's kind of got the idea there, but I'm not going to do so on my computer because I like my space and I don't want to have to clean up all the files, which is going to be fairly easy because I'm going to write it out to a folder. So we've got our output over here and we say, all work and no play makes Jack a dull boy. So let's go ahead but that doesn't take up much space. What would take up a lot of space is me throwing this in a for loop. For blank in range, and let's do it 10,000 times. Right? Eat your heart out, Stephen King. And boom, that actually went really quickly. Right? Now, how much did that take up? How much space did that take up? That's actually 439 kilobytes. Pretty cool. Okay, next. No, that's not enough, though. And writing to a file is kind of annoying. What we could also do is we could totally, and so first off, I'm going to go ahead and write this to a folder instead. So that's a part of the other reason I want to teach you that basically if you create a folder, you can access it by going folder name / and then the file you want to write to. So that's done. And you now have a new file in there. Okay. And now let's go ahead and turn this up to 11. So for I in file, sorry, for I in range, let's do another 10,000. Indent everything in here. We're going to write a file, but we can't just write the same file each time because what's write mode mean? It means we overwrite. So let's go ahead and do some string concatenation here. Plus I, right? So now we're going to write output 0, then output 1, then output 2. We're going to write out 10 files and go. Can only concatenate ints, not strings. Sorry, strings, not ints. So turn this into a string. And go. And now it's taking a bit longer, about 10,000 times as long as we did. See, and we can see that basically that it is still outputting. And we can see our progress. It takes quite a while to write that many files, each of which, by the way, is only 444 kilobytes, which really doesn't take up too much space at the moment. But actually, it's taken up 692 megabytes. So this isn't so much malware as an annoyance because the appropriate way to get rid of it is just hit the delete key, you know? But the point I'm trying to illustrate here is that a way a lot of viruses work and worms or ransomware is that programs just assume that, you know, that the user is doing what they want to do, that if they run something, they meant to run it. I did suggest don't write it. So we're about 4,000 of the way through. I think I will terminate this program. I said I will. Oh, right. Stop button up here. Boom. So let's see where we stopped at. Right. We got all the way to 4,672, which if we look at the properties over here was 2 gigabytes of data. So, you know, and that's a substantial amount. So malware programs recognize signatures in some files, and they're typically, you know, they're not designed like programs like this. Writing files are fairly inane. Nobody really does it because, you know, let's go ahead and go to Task Manager. I mean, even for it's not too hard to recognize. What has got my 100% CPU right now? I'm curious. Folding at home. Oh, okay, so it is running. Yay. I'm surprised. So probably would have run a lot faster if I didn't have folding at home running at full throttle. Folding at home, by the way, if you're not familiar with it, is a collaborative effort to do protein folding, which helps research how certain diseases happen. So this is a way we can generate this kind of. It's more of a nuisance, but it's interesting to see. It's also interesting to see that you can easily do this kind of thing by accident, right? In which case, the way you get rid of it is just simply you see where the output is. And, you just simply, do that. Now, of course, if you wanted to make it more weaponized, you would just simply, have it write random files to random directories on random places in the computer. But again, there's kind of no point for doing that because you're just wasting space. Worst case scenario, they use up all their space and then they wipe their computer and start from fresh. Right? So this kind of thing isn't that effective to begin with. But the way ransomware typically works is using an encryption algorithm. And what they'll do is just scramble your, could you DDoS someone with this? No, because that's a felony. Can you denial of service attack somebody with this? Not really, no. This is not something you run. This is not something you have some, what I'm trying to show is an example, a very stripped down example of certain things. That's exciting, but I'm pretty sure that essentially the only way you can't commit a crime is just simply by sitting at a table and keeping your hands in plain view at all time. And even then, I'm pretty sure you'd still be able to be charged with loitering. So, you gotta know what felonies are in order to avoid doing them. And it is very shocking for people to realize that technically using their friend's phone without their permission while it's unlocked could be considered a felony. It is, but computer data, but computers and, computer crime is not taken lightly by authorities. Yeah, I know Zoom ain't that great, but I mean, the alternative is no school. Unless Zoom University, you mean something more specific than remote learning. Now, okay, so let's see. We have 20 minutes left, and I'm not sure if that's enough time to write this out, but I think I will show you what I did last semester with this and show you some of the file reading that we did, which is, let's see, Madlib Maker. So this was this is actually a fairly straightforward program that we did. And the idea here was that we worked with, is that I did some Mad Libs in class, right? So here I had a text file, the minister for noun, first name, plural noun, and basically anywhere that we saw anything with brackets, we asked the user to input something and store that line. Oh, and I remember where I copied this from. This was from the, I think this was from the Second Emu War. Yes, you heard me. The Second Emu War. the second time that Australia declared war on the emus and lost. Yes, that one. I think there were two. Might have just been the first one. But anyway, the idea here was for this program, let me move this over here, is that we took this file, okay, and what I did is that, let's go ahead and read this. I read the lines, and then my output was just simply, you know, what all the, was simply what would get put together. So I would read each line. So remember, each of these would be, so this gets stored in a big list. And for every string in that list, every string was a line. So I'd go through the line and I'd split it by space. That's what this does. And then I'd say for each of those words, so the minister for, if the first, so first off, if the character was a open bracket, we did something special with it, which we'll go into. And once we were done, we would just simply say, hey, take the new line we have, take the word we had, and put a space back onto it. Now, if we encountered a bracket, what we would tell is we'd ask the user to enter a appropriate word. So if we saw bracket noun, we would ask them to enter a noun. If we saw first name, we'd ask them to enter a first name. And if the word, so if the last thing for the word was a colon, then we said word is equal to whatever the person was ad-libbing. Otherwise, it was equal to whatever that last character was. So running it, it looked like this. Please enter a noun. Taco. Andrew. Plural noun. Let's see. Emus. Direction. North. West-ish. Verb past tense. Throttled. Plural noun. Let's say phones. Crop. Oats. Plural noun. Bananas. So the Minister for Taco, Sir Andrew Pierce, said today that acting on the information which was appeared in the Eastern press in regard to the use of personnel of the military forces with emus, which had been provided at the request of the state government of Northwest Australia, and farmers whose crops were being throttled by the incursion of large numbers of phones into the outer fringes of the oats belts of the state, he had withdrawn the personnel armed with bananas. It's a fairly simple and short program. The idea is just to have a file in the correct format. You read the file, and if you want more than one file, what you do is you basically say, okay, I'm going to grab a list. You use a couple of the operating system instructions to grab a list of all the things that are in that folder. In fact, I could show you how to do that right now. Import OS. Let's go ahead and see. Can we do that? No, it's sys. Oh, no, I'm not in Python. That's why. Python. And now, how do I get a list of all the folders in the file? So go to Google. Okay, Python, get list of files in directory. That's exactly what we want. Stack Overflow, and it was listdir. Right, we'll get you everything in there. Or you could walk it. I just want a list. Just want a list. Thank you. os.listdir. So over here, import OS, which imports operating system stuff or useful operating system kind of commands. list dir to get all the list of all the files in the directory, right? And then if I want to choose one, and let's say I had multiple Madlib files, okay, how would I choose one at random to make a game? Import random. And then I would just simply say random dot choice. Random dot choice is actually a great one. Random dot choice os dot list dir. So choose randomly from the operating system list a file. So it's pretty cool. There's a lot of stuff you can do with files. If you're working in this class and pretty much a lot of other classes, unless you're working on a program that requires a lot of files, using operating system commands like this is not something you're going to need to know at all. On the other hand, reading from a file is, at least in a lot of my homeworks, a fairly common task. So let's go ahead and take a look at the lab that you are going to be doing tomorrow before we just do that. What is the purpose of the if-else statement? To be honest, I don't remember what the purpose of the if-else statement was. I cannot remember what bug that was trying to get rid of. I'm sure if I rewrote it, it would look different. I didn't have enough time to do everything today because, you know, but I still wanted to just show you that idea. So let's go ahead and go to Canvas and just show you the turtle in the last 5 minutes of class. So for those of you who don't understand, who haven't checked it out yet, your homework is the extremely apropos hurricane tracker assignment. I didn't mean it for it to be apropos, but there we are, staring down the barrel of Hurricane Delta. So anyway, you're going to want to download this thing called starterfiles.zip. This is very important, by the way. Download this, okay? Let's go ahead and download this to my desktop. Download it to where you want to work on it, okay? You can unzip it and then rename it whatever you want. But the important thing is that you stay in this file, okay? Or you stay in this folder. Do not move this somewhere else. Do not do this somewhere else, because this file requires being able to read from these other two folders. If you move this file to, say, your desktop or somewhere else, it won't be able to find them. So don't move this file. Unzip this folder. This folder is the entire project. It's going to look something like this. So VS Code, come back here, VS Code, and again, just drag and drop, and look. So it says import turtle. Great. You know what that line does. Awesome. Def Irma setup. Okay, that's a function called Irma setup. And now it's, oh, so somebody wrote some documentation here because this looks really scary. Okay. It says creates the turtle and screen with the map background and the coordinate system set to latitude, longitude. Return a tuple containing the turtle and the screen. Do not change the code in this function. In all caps. Okay, so I can just kind of fold this up. Great. Right? Don't have to worry about that code. Def Irma animates the path of Hurricane Irma. Here are my variables, TWN map background image. Your code to animate Irma goes here. In other words, it goes here inside this function. So in other words, all your code is just going to go down beneath here. Okay. Now let's go ahead and look at what the objective of this is, which is that you will use the turtle module to create an animation of Hurricane Irma's path. In the file are two functions, Irma setup and Irma. Do not modify Irma setup. Modify Irma. Okay. And what you're going to want to do is you're going to in the zip file, there is a file named irma.csv. So let's go ahead and look at that. So there's a bunch of hurricanes over here. Let's grab irma.csv. And we see it says date, time, latitude, longitude, wind, pressure. So this is all kind of information, latitude, longitude information. This is grabbed from Weather Underground. And basically you'll read this file and move the turtle accordingly. The first line, here's the first 3 lines of the file. The only columns that are relevant to your code are latitude, longitude, and wind. The reason that it is, if your file is immediately disappearing, by the way, I highly recommend that you do turtle dot done? Yeah, turtle.done to make sure it doesn't disappear. Because otherwise it will disappear when you're working in, if you're not working in idle. So what you're going to need to do is use your turtle to draw the path. Okay. It's not nearly as, so this may look hard, but it's not nearly as hard as it seems. Because what you need to do, so let's see what the output is. Yeah, there might be some issues with tkinter. Just update your, update tkinter if you need to, or update Python. So this is what we'd be expecting for the output. Something like this. So what does this do? So I got asked, what does this do? Well, this is a tuple. This has a tuple that holds 3 variables. Specifically, it's holding what's returned from this. It returns the turtle on the screen. So it is not as complicated as it seems. But the idea here is that the coordinates are now mapped to latitude and longitude rather than X and Y. And it is not as hard as it seems, I should say. The first thing you want to do is have your turtle follow the latitude and longitude and try to track that. And then you'll want to adjust, and then you'll want to look up the turtle functions to make your line thicker or thinner. And also draw the intensity. All right, stop sharing. So class is currently dismissed. We will be working on this tomorrow. It is not as hard as it seems, I swear. This is one of those that seems immensely intimidating. But all in all, once you figure it out, it takes about 20 minutes to do.
Bye. Thank you.
Okay.
Professor, last night you said in Discord that you're gonna create like a Google document or a Google Sheet.
Oh yeah, it's already on Discord. Yeah, so if you need so I created a document, a Google form on Discord already.
Yep, got it. Thank you.
So just simply submit that. There's 3 questions: your name, what question you need me to grade, and your opinion of Happy Feet. So
got it. Yep, thanks.
Okay. With yeah, for tomorrow, the Friday labs, and also Monday labs. This should be fairly, the Macs are actually great for programming. The only exception is with tkinter. The only in that case, I would just simply download and install the latest version of Python. That seems to work. Python just got updated to Python 3.9. So just simply go to python.org here. So if you're running a Mac, and let me share my screen one last time. Also, I have a lot of grading to do, so I don't know if I'll be able to, if I will be able to stay behind for demos today, but I should be able to do a lot of demos tomorrow's morning during lab. So just simply go to here, hit downloads. It should come up with an automatic download if you're on Mac, and it should automatically be able to identify that you're using Mac OS. Just click it and install it. So here, right, you would download it and you'd be able to install, let's see over here, the Mac OS installer, right? But clicking that download link for your operating system will automatically link you to the right one, right? So I don't think I can handle demos today because I have a lot of grading to do for my other class. They have an exam that they've been waiting on for me to grade. But if you do, but if you want me to, but I'll stay behind and work on the dekinter just to make sure that the students who need it will have it for tomorrow. Okay. Okay.